Hi, this is Akash. I am from the Department of Computer Science and Engineering. I studied in Veltech Multitech, Dr. Rangarajan, Dr. Sakuntala Engineering College. So here we are for project work, and the group of students who named M. Somasundram, S. Srinivasan and S. Akash is performing here and doing the projects. So our guide is Dr. V. Patsaradi, ME PhD, who is the Dean of our Department of CSE. So furtherly, we go to the information. What we want to know is our project name is tackling information fiddlers using the clustering in high density WRAN. So our crew members are M. Somasundaram and Srinivasan and S. Akash. So the overall flow is we are representing here abstract existing system, disadvantages and proposed systems, and the advantage of proposed systems, literature surveys, and the requirements for our projects, and architectural design of our project, and data flow design, and module list, and the references. So further we are going to see the abstract, and before seeing the abstract, the main concept is to find the unauthorized users who are using the spectrum. So there are two types of users. One is the primary user and secondary users. So the primary users are using the spectrum with pay for it, and the secondary users who are using spectrum in there it is free. So the hackers were using the spectrum without any authorization, then there occurs a resource scarcity. So what is the resource scarcity? The resources are get scarcity, they get reduced, and the actually the concept of this abstract is there is an increase in users of spectrum, but the spectrum is getting scarce. This is the concept. And the existing system, in the existing systems, the IEEE 802.22 is a standard for a WRAN. The WRAN is a wireless region area network. So it recommends, in the existing system, it recommends a collaborative spectrum sensing to avoid the unreliability of individual spectrum sensing while detecting a primary user signals. But in the existing system, it opens an opportunity for the attackers to exploit in decision-making process by sending a false reports. This problem, commonly known as spectrum sensing data falsification (SSDF) attack or bicentennial attack. So in the existing system, there is a main disadvantage is a bicentennial attack. It cannot defend against bicentennial attack, and the main concept is the hackers. The hackers can use the bicentennial attack and send the false reports to the base station and can access the spectrum. But in the proposed system, the control of bicentennial attack is based on the strengthening the decision making algorithm of the base station. So we are getting a decision making algorithm which is used in the base station to reduce the or control the bicentennial attack. So the complexity of the proposed adaptive repetition based clustering algorithm is low when compared to the existing algorithms. So the proposed system will deal with both independent and collaborative attacks since the defense mechanism applied to the decision making strategy of the base stations, and the error rate of proposed system is also reduced to the best because the algorithm uses several iterations based on repetitions before taking a final decisions. And the advantages, wherever we can see to the proposed system, there's more advantages is spoken there. And here there's a no node of attackers identity or histories, and the input of the algorithm is only spectrum reports, and the usability of the spectrum reasonably improved when compared to the existing systems. The status of the network is tracked, and this information will be useful for speeding up the algorithms. And we just move to the software requirements. In the software requirements, we use the Eclipse, Juno, and NetBeans 8.0, and the database server or SQLite, and database IDE or SQLite browsers. The hardware requirements are a Intel Pentium or Intel Core i5, and the RAM is a 512 MB RAM or 2 GB RAM, and 750 MB of free space to 1.5 GB of free space of disk size. So the proposed architecture are primary users has sent the uninterruptible spectrum availability, and the second users uses the spectrum when it is only free, but the hacker sends false reports to reduce the spectrum usability. So the box of the base station is giving the workflow of the base station. So first the provides an uninterruptible channel availability to the primary users is the work of the base station, and then it performs efficient decision making algorithm to identify the false spectrum reports, and then only it allocates spectrum to the secondary users. So this is the proposed architecture for us, and the data flow diagram is here. The primary users, secondary users, and attackers who uses spectrums and sends the spectrum report and sends the false spectrum report from the attackers. So in that also it receives the spectrum report and perform the ARC and taking decision and allocate the spectrum to the users. So this is the work of the base station. Then yeah, here is what is the base station. What is about a base station? The base station does not have any information about attacking strategies or a number of attackers. So the only information available to the base station is the sensing reports sent by the users to attach to it. So through these sensing only we are going to cluster the nodes and we can find the fiddlers. So algorithm, what type of algorithm we are using here? We are using the adaptive reputation based clustering algorithm. So in the existing systems they can only defend against the independent attacks, but in these proposed systems we use the adaptive reputation based clustering to defend against the collaborative that means a bicentric attack. So they actually nullify the influence on the final decisions only. So the modules we are used here is determining the channel status. So determining the channel status is whether the channel is free or not. In the primary users implementation, then only the base station assign the spectrum channel to the primary users, and then spectrum sensing and the implementing the ARC. So then the spectrum sensing is used to whether the spectrum is get free, then it can be allocated to the second users. So between that we are going to implementing the ARC to find the whether the fiddlers is there or not, and then only it responding to the secondary users. So here we are working in the Eclipse. So we are seeing see the screenshot of our works on the codings, and here we are going to see another emulator of Android device which is going to show our workflow with a picture of a screenshot, and then the references we are going to see here. And then thank you for this. And here we want to see another video which is our workflow video. Just wait for a sec. And yeah, this is a video which we are going to work in there, and this is the coding sport. And here we are going to first see the server side scripting our codings, and it getting run, the server get run, and then yeah, they get the server get run, and we're going to log in the admin section, enter the username and password, and get login. And when the channel is free, it accepts the secondary users. So here is the video which yeah, here's the console, and we are using the ARC, and we run the ARC here. We're getting the ARC is getting running. This is the emulator. We are seeing we're getting it to on two screens of primary users and secondary users. So the primary users is the paid users who enter their username and password and the server IP in it. Then use the connect button to get connected with your server or base stations. So here we enter the wrong IP. Yeah, the channel get busy in the base station. This is the base station, and we get logo, then we get the channel get free. So then we can use the accept secondary users, and for the decision making screen can appear here. and we use a free server base station now. So we can check the channels and use the port number and signal strength. The channel is free, we can use this spectrum. So we use the various port number and the various signal strength and giving signal request. So whether the two or more secondary users are giving these port number and signal strength. So here is there is a request from the five various ports with the various signal strength, and there is another entry. So there is 6 various ports with the various signal strength. Here we go to create the clusters. So this is the main concept of our project. So the automatically the clusters is creating, and according to the distance weighted it will create the weight. So this is the honest values and this is the malicious values. So this is the strength and the values are represented here, and alligator spectrum. When we click the alligator spectrum, it will works like this. The spectrum report clusters will be reported here. The cluster 1 and the cluster 2. So the cluster 1 is honest users and the cluster 2 is the cluster 2 is the malicious values. So here we go to check how the base stations work. So we response and get file. The file transfer, we just use the file transfer to see whether the base station is working or not with honest users. So here we go to select any document files. I get a backup, and here I go to select admin, and we are setting yes or source files, and that's a JPEG file. So we go to transfer it. We go to send button, and it is sending to it, and in the base station we go to receive it. From the base station we go to receive it, so we get file received and stored at our local storage. Okay, we are going to entering into the device, which is emulator. So in the emulator there is a various storages. In the storage of SD card we are going to see the received file named as f.jpg. We are getting received from this. So we have the communication with the base station and our Android device. So this is main concept of our project, and thank you.